how does it move around in a system? Energy is going to be a new variable for us. We're going to use E to represent energy, and the unit of energy is the joule, which is a combination of a couple other fundamental units that we're not going to go too far into, but if you have questions, I can help you with that on the side. Energy is the potential to make something useful happen, or the ability to work. A lot of you have your own definition of what energy is, and for the most part, you're pretty much correct. The more energy you have, the more jazzed you are to go out and get things done and make stuff happen. And of course, when you don't have energy, you're not really feeling like you're capable of getting things done. We think about energy in two types in physics. Our two major types are kinetic and potential energies. And we're going to go into more detail about what these types of energies mean and how they're different from each other. So the first type of energy we're going to talk about is kinetic energy. Kinetic energy is energy in objects that are moving, or they have parts of them moving. And we're going to go through some examples of kinetic energy right now. The first type of kinetic energy that I want to talk about is motion energy. It is the energy that objects have if they are on the move. And we're going to call this EM. Is going to be this symbol with a little subscript M. And as you can imagine, there is a formula for this, and it has to do with their velocity as well as their mass. An example of something that has a small amount of motion kinetic energy might be a little turtle walking around, and something that might have a comparatively large type of motion energy would be a race car. The next type of energy we'll talk about is rotation energy. This is the energy associated with an object or part of an object spinning. Something that might have a small amount of rotation energy might be a bike tire turning, and something that might have a larger amount would be a whole planet. The next type you might be more familiar with, which is thermal energy, ET, and any object that is not absolute zero has some thermal energy. And if you had a microscope and you could zoom in on the particles of any object, you might see that they are vibrating just a little tiny bit. Especially if you are observing them, they'll vibrate a little bit more. So ice has a very small amount of thermal energy compared to something that's hotter, let's say lava, where their atoms in lava will be vibrating a lot faster. Then we have light energy, and light energy is a type of energy that's produced from photons projecting from an object or something that's a source of light energy. It could be lots of things, and an example of a small amount of light energy might be the light that comes from a flashlight, and a larger amount might be from a laser. And the final type of energy is EW, wave energy. And we're going to focus a lot on this one later on. In fact, we're going to do an entire unit on wave energy. But anything that travels in waves, and a little bit light is included in this, but sound, liquids, things of those nature, air, has what we call wave energy. So an example of something that has a small amount of wave energy might be a whisper, and something that has a large amount of wave energy might be a tsunami or an earthquake. Potential energies. Objects have potential energy if their shape or position stores energy. There are lots of types of potential energy. The first one we're going to look at is gravitational potential energy. This is where an object's mass and the force of gravity combine to create stored energy that could be used to do work after it gets converted into kinetic energy. An example might be snow, as something with a small amount of gravitational potential energy, and something with a large amount of potential energy might be a space shuttle up in space, where it could potentially fall and create a great deal of destruction on the ground. The next type is electrical potential energy. Something might think of is static electricity, and a small amount of electrical energy might be just a single electron that can transfer from one place to another. A high amount of electrical energy could be a high voltage power line. The next type of potential energy is spring or elastic energy. This one you're probably pretty familiar with if you've ever pulled back a rubber band or pressed a spring together. The bouncing back is that energy that's released from the spring. And the tighter the spring or the rubber band and the harder you pull it, the more potential energy it has. So something that has elastic potential energy, a small amount might be a rubber band, and then the shocks of a car, they have a lot, right? So they're hard to push in and they push back even harder than something like a rubber band. Another type of stored energy is chemical energy, right? So the bonds between atoms are able to store energy and do different things with it. So, for example, we store energy in food. So maybe a small amount of chemical energy is a peanut, and then it'll go in our stomach and we'll break it apart for energy for us. A large amount of chemical energy might be the chemicals stored in a battery that will be converted to electricity. And finally, we have nuclear energy. And anything with a nucleus and some atoms will have a little bit of nuclear potential energy, although things can have a great deal of nuclear potential energy if engineered to be. So nuclear reactors or stars have a great deal of nuclear energy. So with our energy, we can draw a closed system around it, and it will match our big theme of our last unit, which is conservation, so that the total number of joules that we had in the closed system will be consistent over time. But that doesn't mean that energy is not affected. It can be transformed from one type to another. So it could go from gravitational potential energy to kinetic energy, or electrical energy to mechanical energy. And it can also be transferred from one object to another. So electricity can move from atom to atom. Kinetic energy can be transferred in, for example, a collision of marbles. One marble can crash into another and give it its kinetic energy. And so if we create a system, we can watch energy move through that system and transform through that system. So transform and transfer, but the total amount of energy will be conserved. So we're going to look at how energy is transformed from one form to another. And the way that it happens is a process called work. Work is the transformation of energy from one type to another. And a very common type of energy transformation that happens on Earth is falling. So here we have the Granny Skydiver, and it converts one type of potential energy into a type of kinetic energy. Can you guess what that is? I'll give you a moment. If you guessed gravitational potential energy to the energy of motion or kinetic energy, then you did a good job. We can also have energy transformed from chemical potential energy. We've got this young lady and she is working her muscles and she ate some food and she is going to spin this ball, which is called a zorb, and we're going to go from energy chemical to energy rotational as the ball spins. Now sometimes in the process of energy transformation or energy transfer, you may have unintended changes in energy, and you might think of this as wasted energy or inefficient energy use, but that doesn't mean that it's gone because energy is still conserved. So it's the same number of joules that get changed from one type to another. It's just that maybe you have a collision, and instead of transferring all of the energy from kinetic energy to kinetic energy. Some of it gets turned into sound waves or to heat, friction from that collision. So that's waste energy. Our next big idea is energy transfer, and that's energy moving from one object to another. If we apply the laws of conservation, this has the implication that all energy can be traced back to the Big Bang. So let's give it a shot. Let's have an example. Let's say you have a light on in your room. Well, motion energy from the Big Bang is transferred to gravitational energy in space dust, which transferred to nuclear energy in the sun, which transferred into light energy from sunlight, which transfers into thermal energy in environmental heat, which transferred into gravitational energy in evaporated water in the atmosphere, which transferred into motion energy in the Columbia River water, which transferred into electrical energy in your wall socket, and finally transferred into light energy in your light bulb. So it all gets conserved, it can all be traced back. So in summary, you should answer your essential questions, which are: what is energy, and how does it move around in a system? So fill that out in the summary section of your notes, and then you should also fill out the graphic organizer and work on the extension questions to help you be prepared for our next class. Thank you for listening.
Are you here with me? Just looking out on the day of another dream, where you can't get what you want, but you can get me.